Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, California Resources Corporation, Kern Schools Federal Credit Union, Panama Buena Vista Union School District, Bakersfield City School District, and the San Luis Obispo County Office of Education, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
We're here live at Longfellow Elementary School, home of the Lancers, and today we're all here to...
Well, good afternoon and welcome to Do the Math. I'm Michael.
And I'm Tracy. And if you want to get a hold of us here, we're at Bakersfield, 636-4357. You can get us at San Luis Obispo, toll free, 1-866-836-6284. We have email, dothemath@kern.org. You can watch us online at dothemathonline.net.
All right, don't forget, we've also got a lot of things on social media and things like that, so keep an eye out for those things. We have a very special guest in studio, and we also have a couple of things going on today. Today and tomorrow are the final 2 days for the 5th grade call-in contest. At the moment, we have 4 schools that are tied. So 4 schools that are tied for the 5th grade call-in contest. So you've got today and tomorrow to finalize that with the 5th grade call-in contest. Also, this week and next week, all 4 days, any student that calls and gets on Do the Math, we will be sending you tickets to Holiday Lights at Com, a wonderful experience, and they've been doing this for a long time. I mean, it seems like years and years and years. I mean, it's got to be at least a decade that they've been going this thing. I'm not even sure. You know what? That's what we need to talk with about somebody tomorrow, because we'll be out at Com tomorrow to find out how long the Holiday Lights at Com has been going on. I know that they've been great supporters of Do the Math, and we always look forward to going out there, learning a little bit more about the different animals that are out there, and obviously the lights and how they change them up a little bit every year, but always a great time for a lot of families. Well, before we get to all of the other math, let's first take a look at today's Math in the News. All right, so Thanksgiving just got through, and you said you did a lot of eating.
Yeah.
As we all did, I'm sure everybody did. Now, another thing that happens right after Thanksgiving, what is that? I mean, you guys
Go to the gym, lots of diets.
So some people do that, go to the gym and start dieting.
Yeah.
Other people will do what, especially the night of Thanksgiving or the next day?
Sleep? No.
Yeah, well, that's what I would be going for. But stores.
Oh, Black
all the
Friday.
sales, Black Friday, right?
Got
Seems
it.
like it's Black Thursday night now, Black Thursday afternoon, and things like that. But anyway, so the holiday shopping season, I guess, is upon us now. So I found an article, and here we can see that there's a photograph of just a couple of boxes, plain brown boxes, right? Mm-hmm. Which people are going to need to send items off to various parts of the country and different parts of the state or wherever they're at to send people their goods. Well, there's another reason that this was in the news. Relief packages for refugees or those in disaster-stricken areas meet essential needs containing food and medicine. So you never know what's in the box. But along with the essentials, there's never enough room for toys for kids. All right? So playing helps them to cope when they're in these disaster-stricken areas. And it's called the Inside the Box. So somebody created this, and that's the way they look on the outside, but then inside
very cool.
and things, this is the way they look. So this was designed by Lizanne Koning. So they contain food, water, toiletries, and other goods when people are displaced from their homes, but it also incorporates games right on the box.
Very nice.
So what they do is they take that, and it was in a design academy in the Netherlands, where they developed this and eventually got it out and useful. But you can see where they can cut out the things out of the cardboard and then make different games and things for the kids to play with right out of the box, which is inside the box, in order for the kids to, so I thought that was a pretty cool idea.
Those are cool.
As people get ready for using boxes to ship out their holiday items. So I figured, all right, let's take a look at surface area of boxes, and this one right now, surface area of a prism. So we're looking at the top, the front, the left, and I do believe, were you on last week when we were doing the one with the file cabinet?
The sticky notes?
And how many sticky notes it'll take to cover that. But anyway, surface area is something that the kids are learning, and typically around, I would imagine, 4th, 5th, 6th grade is when they're learning surface area for the first time. And we can see that you've got the height of the prism, the width, and the length. And with all of those, we can see an example here. If we have this measured in centimeters, we can see that the length is 3 centimeters, the width is 2, and the height is 5. So you're going to go length times width, width times height, length times height, multiply that all by 2. And we can see when you put the numbers in to substitute for the variables, how that all comes out to be the surface area of 62 square centimeters. And that, along with the box, inside and out, is today's Math in the News. 636-4357 is the phone number. We do have phone tutors available on most Tuesdays and Wednesdays throughout the regular school year. And just a reminder, if you're just tuning in, all students that phone in this week and next week will automatically receive themselves a ticket to Holiday Lights at Com. We also have an opportunity for students to win themselves tickets to any athletic event at CSUB, courtesy of our friends at Cal State University Bakersfield Athletic Department. So we appreciate those guys for that. A lot of great things going on. The 5th grade call-in contest is going on right now, and we have a 5th grader in studio. Luke, how are you?
Good.
Why don't you let everybody know where you go to school and what grade you're in? Even though I already told them what grade you're in, but.
I'm in, I go to Stockdale Elementary, and I'm in 5th grade.
And how is 5th grade?
It's good.
Okay. First thing I want to do, I don't want to put you on the spot. Have you guys heard about the 5th grade calling contest in your classroom?
No.
No. All right. So who's your teacher?
Miss Martinez.
All right. So what we're going to do is we're going to send a little thing out to Ms. Martinez tomorrow and make sure she finds out. I'm only kidding, because you know what? I bet you if you go, hey, Ms. Martinez, are you aware of this 5th grade calling contest? She probably is going to go, oh yeah, there's something up on the wall right there probably. So check with her tomorrow and see if she's aware of it.
Okay.
All right. So 5th grade, how's it going so far?
Good.
Yeah. What do you like best about 5th grade?
Probably STEAM.
So STEAM.
Yeah.
So what kinds of things are you guys doing with that? Can you, anything?
Science, technology.
So does anything come to mind that you like about it?
It's kind of like hands-on, so you get to it's not like in a book and like writing and stuff.
Okay.
It's kind of like with technology, you get a code on your laptop, and then
The art?
yeah,
Okay.
you get to do like graphs and then like draw graphs.
So
and
you
stuff.
like doing the things
Yeah.
a little bit differently than just going, all right, here it is in the book, and this is what we have to read, or this is what we have to do, and just doing it like that.
Yeah.
So you like the STEAM activities that your school is doing?
Yeah.
Cool. Well, you know what? I know there are a lot of places that are doing STEAM and STEM activities and things like that. And a lot of students, like you were saying, the science, the technology, do you know what all the letters stand for?
Science, technology, engineering,
Perfect.
arts, math.
Math, there you go, right? The most important one, right? They say the most important one for last, right? So we are going to have you work on math problems from now until 5 o'clock, straight through. Are you good with that?
Yeah.
Okay, I'm only kidding. You don't have to work all the way straight through until 5 o'clock. We'll have you do a couple of problems later on this hour, okay?
Okay.
All right. But you know what? Just a reminder, we do have phone tutors available until 5:30. If you're calling from San Luis Obispo County and we do one of your math problems, you will automatically receive yourself some ice cream, courtesy of our friends at Doc Bernstein's Ice Cream Lab. Right now, we're going to go out. We're going to visit Devin. And I do believe he is ready with some students, ready to do a little bit of math.
Hey, thanks a lot, Mike. Back here at Longfellow Elementary School, right in the midst of a beautiful fall day here in Bakersfield. We've got a lot of friends with us across 4th, 5th, and 6th grade with us today here at Longfellow. And it was really interesting having the conversation about where everybody is and what they're exploring. What we're going to do is we're going to look at a little bit of each of those grades as far as what they're working on here at Longfellow. And we're going to start off with 4th grade. So we had a conversation with some of our friends here about the kind of multiplication they're exploring. And today, the 4th graders here, we're looking at multiplying by thousands. So I thought about this and, you know, why limit ourselves with just thousands? So what you're going to see everybody working on right now are different varieties of multiples of 10. So we have them working on 4 different problems. They're all multiplying 4s, but they're doing different extensions of place values. So we're doing 4 times 2,000. We're also doing 4 times 100. We're also doing 4 times 30. And we're also doing 4 times 2. Now, one of the things we noticed is that there's a lot of different ways in which students are representing their understanding here. So, for example, we're looking at 30 times 4, which is interesting, sir, because, what was your name?
Daniel.
Daniel. What's interesting is that we had 4 times 30 up here, but you represented this as 30 times 4. So, show us what you're doing to make sense of 30 times 4.
So I put it like this, so I can do this. So first I multiplied 4 times 0, and that equals 0. And after that, I multiplied 4 times 3, and then I got 12, and then I got 120.
Now, what's really interesting about what you did on the side here is you saw this as 30 plus 30 plus 30 plus 30. So your 30 added to itself 4 times. So you're using repeated addition to make sense of that. Does that work with some of those other problems as well? So
Yes.
could we do that with 100 as well? So
Yes,
4
we
times
could.
100. So give that a shot. And we're definitely seeing a lot of that same pattern here. We saw that as well with the drawings for the 4 times 2,000. And we see some area models here. Young lady, your name?
Right.
Right. Tell us a little bit about what you're working on here. So how are you doing 4 times? Are we doing 4 times 100 or 4 times
30.
30? So you're doing 4 times 30 here. So explain how you're doing that. So it looks like you're doing 4 times 10, and you're going to do another 10 here, another 10 here. So you're breaking that 30 into 10s, and then multiplying each of the 10s by 4. So this is a box of 40. And I'm going to predict, Mariah, that there's going to be another box of 40 here and another box of 40 there, right? No? How are you going to do that? I'm sorry to interrupt you. I just want to make sure that we can share your thinking with everybody.
Okay, add 40 plus 4.
Okay, so go ahead and continue on that. We're going to get back to you to see what that looks like. You're doing something very similar with 4 times 2,000, correct? So explain how you did this work.
I put 2,000 plus 0 3 times and then did that, and then I put 2,000 times 4, and then 4 times that, and then 4 times, and then I put the answers on
That's
the
really interesting. What was your name?
Jesse.
Jesse? What's really interesting, Jesse, is that you took the number 2,000 and broke it down, each digit by its place value. So what you're saying is you have 2,000s, 0 hundreds, 0 tens, 0 ones, and you multiplied the 4 by each of those place values. That's a really interesting approach. And what it shows is a way to make sense of each of the numbers in a number, each of the digits in a number, even though it's mostly zeros. It shows exactly what those zeros represent. And so that's really fascinating. So it looks like most of us have broken down each of these problems. So everybody, is it okay if we shout out our answers to each one of these? Yeah. So let's give this a shot. Ready? I'll start at the bottom. 4 times 2 equals? 8! Wow, these guys know what they're doing. 4 times 30 equals? 120. 4 times 100 equals? 100. And 4 times 2,000 equals? 800. All right. Now, we found all 4 of those. I have one more 4 times problem I want to see if we can put together. And I think that Jesse's got a clear idea of how this is going to work out now. Are you ready? It's this one. 4 times 2,132. Hey, don't those pieces sound very familiar?
Uh-huh.
Because how many thousands do we have here?
2.
Oh, how many hundreds do we have?
1.
So what do you think we have to do with all the answers we've already found?
Add them together.
So go ahead and try that out. Instead of launching right into an algorithm with carrying over and numbers, we break each of these digits down into its place value, and it doesn't matter which one you multiply first, as long as you add all those pieces together, which our friends here at Longfellow seem to have picked up very, very nicely. So they're going ahead and piecing those all together, which is nice because they've already found all of these values, as you heard so eloquently stated from our group here. So, is there anybody who's gotten a solution already? We've got a bunch. Let's see if we can shout that on the count of 3. 1, 2, 3. 8,528. Looks pretty good to me, Mike. Back to you in the studio.
All right, nicely done with that group activity and doing a little multiplying in a couple of different ways. 636-4357, we do have phone tutors available until 5:30. We'd also like to thank our friends at Johnny Rockets for donating a meal to Luke. So congratulations on coming down and getting a free meal for doing some math work, huh? Not bad?
Yeah.
All right, well, you know what? Let's get you doing some math work now, huh?
Okay.
All right, over to the board. Let's go. So in your book, you are working on, looks like adding and subtracting fractions.
Yeah.
So we're going to do, there's one you haven't completed right now. So 4/9 minus 1/6. So 1/6. So as you go through that, you've got Tracy to help you out, but explain to us how you would go about solving that problem.
Okay, so first you need to find a common denominator, which you can just multiply, and then it would be 54. So, and then 54. So then 6 times 9 is 54. So then you have to do 6 times 4. So that's 24. And then 9 times 6 is 54. And then you have to do 9 times 1 because 9 times 6 is 54. So then you have these, and then you minus these, which is, you only minus the numerators. So
You can work it off on the side if you need to.
15. And then, so it'd be 15 54ths for the answer. So 4 ninths minus 1/6 equals 15 over 54.
Is there any way to reduce that maybe?
Yeah, if you want to simplify, then you can do if you want to simplify, then you have to do simplify both of them.
By the same number?
Yeah, that's the
Okay.
same number. So half of 15. Wait.
It's okay.
Half of 15 is nothing.
So let's just back up really quickly because you're doing great. So this is, no, we don't want to say the, oh, no way, go away. Okay, so real quick, let's think about this really quickly. So we know that 2 can't go in there because this is not an
Yeah.
even number. So can you think of something else that it might be able to go into?
Maybe.
So you
3.
can't do 5. 3 would be a good one. Here, let me put my pen up. Okay, go ahead.
So if you divide by 3, then that would be 5, and that would be, let's see. So that would be 38. No, that'd be 18.
That's okay.
So 5/18.
So 5 over 8?
Yeah.
Okay. And I think we're done with that one, right? And 5 over 18?
Yeah.
So really quickly, remember how we were trying to figure out how to do this? And this was not an even number?
Yeah.
So we couldn't do 2. We can't do 5 because that doesn't have a 5. So there's a little trick. So if you add the 2 numbers, 5 plus 1 is 6.
Yeah.
And if you add 5 plus 4 is 9.
Uh-huh.
6 and 9 both go into 3, correct?
Yeah.
So any numbers you can add them up, and they like a 3, 6, 9. You can always do the 3 into it.
Yeah.
Okay, you did great.
Thank you.
There you go, nicely done. Now,
Yes.
what I'd like you to do is maybe on the other side,
We'll come over here.
go ahead and write 4 ninths minus 1/6 again.
I'm gonna do it here. We'll trade.
So you're gonna do the same problem, but I'm gonna have you do it a little differently.
So
So go ahead all the way over to the left. Yeah, go ahead and write the problem again.
and put a minus there.
So what I'd like you to do this time is, because what you did was correct. You automatically multiply them and you got a common denominator of 54. But sometimes if you get larger numbers and you just do that, you're gonna have a really big number that you're gonna have to work with. So what I'd like you to do is see if there's a lower common multiple, a least common multiple for 9 and 6, so you don't have to work with such a big number.
Okay.
So if there's something smaller than 54 that 9 and 6 will go into.
Okay. So you have to multiply and then keep on doing it until you find the lowest common multiple. So
Can we stop though?
Huh?
Can we stop? Do we see something that we already have it on
18
there?
and 18.
Perfect.
So these two are the same, so that can be the denominator because it's the common denominator. So these can go into 18, and then 6. What can make 6 into 18? So 3, and then 3/18, and then 9 times 2 is 18. So then you minus these.
Hold on one second. So is it 4 or is it?
I mean, it's
You're good.
it's 8.
I didn't want you to have to do the whole problem. We had to do it over. Nice.
And the minus is 5/18.
Perfect.
There you go.
Much
Nicely
easier,
done.
right?
Yeah.
All right.
So we followed along with what you were doing. We know that the 8/18 comes first, because otherwise you would have negative 5/18, but you've got the whole thing right there. So nicely done. You can go ahead and erase that board. 636-4357 is the phone number. We do have phone tutors available until 5:30. Don't forget, today and tomorrow, the last 2 days of the 5th grade call-in contest. Right now, we have 4 schools tied for the lead. And hey, you know what? You've got until 5:30 this afternoon, and then you've got 2 more hours tomorrow. Also, all students that call in this week and next week will be receiving free tickets to Holiday Lights at Com, a lovely family tradition. We'll be back with more right after this. Today we're at Thomas Jefferson Middle School, and today we're here to Thomas Jefferson Middle School, and I've got Victoria, an 8th grade student, with me. How are you?
Good.
You ready?
Yep.
Let's go. Go ahead and read the problem for us. What have we got?
We got 9a minus 2 equals 4a minus 18.
What do we need to do with this?
We need to solve for a.
Perfect. So how would you like to go about starting this?
We can first, we can make a line right here,
Okay.
and like that, so it's like subtracting. We could first minus 2 on both sides.
So you want to get all the numbers on one side and the variables on another side? Mm-hmm. Okay. So here we have a negative 2. Mm-hmm. So we want to get rid of that. So we do the inverse. So what do we need to do to this?
Add 2.
Add 2. Perfect. Because you said subtract 2.
Yeah.
And I think I knew you were talking about. And if we did it here, why are you doing it over there?
Because you have to do it on both sides.
To keep everything balanced and equal?
Yes.
Okay.
So this crosses out. And then this would be 18 minus 2 equals 16. And then it'll be 4a. And you bring everything else down. It'll be 9a.
So the only thing I need you to do right now is everything's perfect. You did the difference between 18 and 2 is 16. You brought down the 4a, the equal sign, and you brought down the 9a, which is the only thing left on this side.
Yeah.
But 4a, 16, are we going to add 16 or take away 16?
Probably
Because what was the symbol we already had?
subtract.
Subtract, right? Negative 18 and 2 leaves us with a negative 16, right? So we'll leave that a negative 16. Okay, now what would you like to do?
Probably the 9.
What do you want to do with the 9?
I could subtract.
You want to keep all the variables on one side?
Probably, yeah.
Okay, so if we have only a variable over here, what should we do with this?
Take it away.
Move that over here, right? Okay, so is that a positive 4a or a negative 4a?
Positive.
Positive. All right, so in order to get rid of a positive 4a, we have to, just like we did here, the inverse, right? So we'll subtract 4a.
And then on here,
Right, both sides, remember? Keep everything equal.
cross this out. And it'll be 5a equals 16.
Positive or negative 16?
It'll be negative.
Negative 16. So now what do we need to do?
Divide
Divide by what?
5.
Perfect. And why are we dividing by 5?
Because the 5 is next to the variable, so we're going to take away the variable.
Right, so that's the coefficient, so we'll get rid of that.
And this crosses out. A equals, and then you'll do negative 16 divided by 5.
And we could just leave it in that form also, right? Okay, so why don't you just go ahead and leave it like that? And we solved for A. Victoria, nicely done. And once again, a big thanks to all of the staff and students at Thomas Jefferson Middle School. Always have a great time when we have the opportunity to go out and do a little math in your class at the various schools throughout Kern County, as well as San Luis Obispo County. Hey, if you'd like us to come out to your school, all you have to do is give us a call. The phone numbers are at the bottom of your screen periodically throughout the program. Simply let us know, hey, you know what? We'd like you guys to come on out, do a little math in our class as well. We'll take a look at the schedule, see when we can get you guys in. All right, right now we're going to go out and do a little math at their class at Longfellow with Devin.
Hey, thanks a lot, Mike. Back here at Longfellow Elementary School, home of the Lancers. I'm joined by Angelina and Scarlett, 5th grade, and today's lesson focused on powers of 10. Now, it wasn't really today's lesson. You started looking at this yesterday, but could you just kind of explain to us what exactly powers of 10 means?
You're most likely counting by tens.
So when we say counting by tens, are we going like 10, 20, 30, 40?
No, multiplying it.
So,
You're
so
multiplying it.
it's the number of times that we multiply a number by 10. Now, that can look a lot of different ways. And what we're going to be doing today is exploring what happens to numbers as we multiply by powers of 10. So right up here on our smart board, we have an example of 10 to the second power. Now, explain to us what this means.
That means like 100, because it's 10 plus 1, times. It's most likely 10 times 10.
So 10 times 10. So what does this number 2 have to do with anything?
It's telling you how many times to time it.
So the powers of 10, that number, the exponent above the 10 to the side, tells us how many times we're going to be multiplying with 10. So we have an expression that uses multiplication with 2 10s in it. 10 times 10, which we know equals 100. Right. Okay. So now let's have a prediction here. If I was to put up 10 to the third power, what would that expression look like?
It will be 1,000 because you're timesing the tens 3 times.
So we're multiplying with 10 3 times. So it would look like this. That's 2, so we're going to need 1 more. Now, what do you notice happened with the number of zeros as we went from 10 to the second to 10 to the third?
It added up.
So because the exponent is 1 more, there's 1 more 0? Now, what's also interesting is if you look at the total number of zeros in the tens that we're multiplying, what does it have in common with the number that we have that we end up with?
It's the same zeros.
So how many zeros do we have here?
2.
So how many zeros do we have in 100?
2.
And what is the exponent for 10 to the...
Second.
So we start to see how that 2 ends up showing up a lot. Does the same hold true with this, with 10 to the third?
Yes,
How so?
because it has 3 zeros in the timesing, and it has 3 zeros in the answer.
So when we say this, so when we're multiplying with 3 tens, we're really multiplying with 3 zeros, and we end up with a value that has 3 zeros. So your challenge, everybody in the room is going to be working with this, is to try to fill in what they think 10 to the fourth would equal, and 10 to the fifth would equal, and what that expression would look like. So they're going to work on that, and I've got a challenge for you. They're working to greater exponents. We are going to work with lower exponents. So following this pattern, what do we think 10 to the first would look like?
It's just
10 times 1.
Just 10? Well, I think we're getting to the idea that it's 10. Are we necessarily saying 10 times 1?
it will be like
We have an expression that uses multiplication that only has 1 10 in it, right? So really we don't need a multiplication symbol. Now, with that said, you notice a pattern. 10 to the third has 3 zeros. 10 to the 2 has 2 zeros. 10 to the first has 1 0. So, what do we think 10 to the 0th power would be?
0.
Now, let's see if we follow this pattern. Your guess is that it's 0. Why do you say 0?
because it has no other zero.
And if you multiply 10 times 0, it would just equal 0.
Now, are we necessarily multiplying these two together?
No.
No, all we're saying is how many tens are in that multiplication. Now, I want to go back to this pattern because I think this is really helpful for us to build understanding. We have 1,000 for 10 to the third. I think you're starting to see something here, right? We take away that 0, we're left with 100. We take away this 0, we're left with 10. So what happens when we get to 10 to the 0th power and we take away this 0? What is left?
1
So 10 to the 0th power
equals 1.
equals 1. So the fascinating thing about 10 to the 0th power, as you explore powers of other numbers that aren't just 10, is that no matter what that base number is, if the exponent is 0, it'll always equal 1. So you can have 3 to the 0 power. It's 1. You can have 999 million to the 0th power. Equals 1. My challenge to you, and this is going to go next level, and if we don't work on it now before we send it back to the studio, and if you're thinking about this at home, use the pattern and think about decimals too, okay? What about 10 to the negative first power?
You're going to start using this.
You're going to start looking like decimals, right? So what do you think this would be if we follow this pattern? 1,000 divided by 10, divided by 10, divided by 10. Because that's another pattern as we go lower, right? Because if we go up in the exponents, we're multiplying by 10. But if we go lower in the exponents, we're really dividing by 10. So 10 divided by 10 is 1. How would we express 1 divided by 10? What would that look like?
It will probably look like like really nothing.
It'd be a very small number. You're absolutely right. But do we necessarily have to use a decimal to show that? Because there's another tool in math that we use to show division. A fraction. Right? If we think about 2 divided by 3, we can write that as 2/3. If we write 1 divided by 10, how could we write that?
1/10.
1 tenth. And if we put that as a decimal, 0.1. Now, what do you notice about the number of zeros in this fraction, in the denominator? There's 1. I want to see if Angelina and Scarlett can rise up to the challenge of 10 to the negative second power. And I want to see if you at home can do the same thing as well. But for now, we're going to send it right back to Mike in the studio. Mike,
All right,
take
thanks
it away.
for that,
We
Devin.
got our work cut out for us.
All right, maybe we'll have Luke do that while he's waiting next time we go out there and visit with you guys. But nicely done by Scarlett and Angelina working out there at Longfellow Elementary. We do have phone tutors available until 5:30. Right now, it's time to get Luke back to work. Back to the board, young man. No more of the easy fraction like you were doing before. Now we're going to add mixed numbers.
Okay.
All right, so here's one out of your book. Let's 8 1/6 plus 7 3/8. So explain to Tracy, if you would, how you want to solve this problem.
So you'd put this number back up here, and then so that'd be 10. No, it'd be because
So first of all, so what does 8, and let's try it with 8 real quick. What does 8 represent?
this it like you can divide. This number was 8 times.
So 1 whole of these would be equals 6 over 6. So
Yeah.
before you do this part, you have to 6 times 8 and then plus 1.
Okay.
So go back to that one, and then I'll let you do that one.
So 7 times 8 is 56.
And then you have to
And
add.
then add plus 3,
Perfect.
so 59. I'm going to erase this. Okay, so 59 eighths plus 48 plus, so 40, 49, 49 sixths.
That's good. No, go ahead. You can write plus right here.
Plus
And then
59 eighths. So then,
hold on 1 second. There you go.
common multiple, and then so 8 and 6, and then 16, 12, 24, and then 18, and then 24. So then 24, 24. So 24. 20.
So 6 times what makes 24?
4.
And then 4 times 49. So we're making you do the long way, huh?
Yeah.
I'm going to show them how to do the easy way. So 8 times 24
is 3.
3.
So 59.
You can come over here.
Is 3.
Hold on 1 second. Let me move it up for you. There you go.
27. And then 15.
And you forgot to add the 2.
17.
I didn't want you to get through the whole thing. And we were
Yeah.
like, oh, wait. There you go.
So 177.
Do you want to
plus-
rewrite it?
Yeah.
Okay, so hold on. Let's go back down, or we're going to rewrite these two right here.
196 over 24 plus 177 over 24. So 196 plus 177 is 4.
Well, hold on now. You got 1, 9, and 7, right?
Oh, yeah.
So it's just this one right here. So we're going to erase that, and we're going to erase that. So we have 9 plus 1 is 10 plus 7. So that's
Oh, I
17.
multiplied. I multiplied.
So
16.
So
yeah,
it's 17.
3, so
So it equals?
equals 374.
73.
Oh,
I like how you do money, though. I'm going to have you do my checking account, though.
73.
'Cause you keep adding lots to it.
24.
Perfect.
So, where's the original one?
I would say go all the way over to your left to do your division
So
now.
let's come over here, and we're going to do the 24, and we will divide into 373. No.
So 24 goes into this once.
Hold on real quick, just so we don't mess it up. Okay, now go.
Okay. 3, 13. So bring this down. And then 133. Divide by 24.
So this
This just helps so much.
So this is how we guesstimate kind of in our class, or an estimation. So I kind of make that 25. So I go 25, 50, 75, $1, $1.25. So it can at least go 5 times. So
Okay.
you can try 5 first.
5 times 25.
Well, 24.
10. So, yeah, it'd be 5.
Okay.
So 5, 120. That's 13.
So how about we leave it right there, and we'll do 15, and we'll do 13 over 24. Okay?
Yeah.
Now we're going to do it the easy way?
Right, so remember that your answer is, I'll just go ahead and jot it down in his book here, 15
Okay.
and 13 over 24.
Correct.
Yeah.
So let's go back to the original problem. You guys can just get rid of all of that if you want. We'll rewrite it.
Okay. So, I forgot I have my handy letter. There we go.
There you go. All right,
Okay.
so we have 8 and 1/6 plus 7 and 3/8.
Seven and 3/8. So, the easy way?
Yeah, the easy way.
So 7 plus 8, 15. And then,
So I'm going to cross these off so we know we've done it, okay?
Okay.
So this one and this one are now here, okay?
Okay.
So now we'll do
So-
the fractions.
1/6 plus 3/8.
And we already know the
common
common.
denominator is 24.
Perfect.
And then 6 times 4. So 4. And then 24. This goes into 24 3 times. So 9. And then, so 13. 24. So 15.
Phew, that was way easier
Yeah,
that
it was
time
way
than it was,
easier.
You
right?
like that way? All right, so why don't you erase the board so you came up
Okay.
with the same thing right there. So
Okay.
now what we'll do is we'll go ahead and we'll do a subtraction problem and see if it works out the same way, like that.
Yeah.
All right, so here we go. 2 and 5/8 minus 1 1/4.
So the long way?
Mhm.
Okay. So 1 times 4 is 4. And then 2 times 8 is 16.
Okay, so you just real quick. So we forgot to add it. So 4 times 1 is 4, but we have to
Oh, yeah,
add the
plus
1.
1.
So it's 5. You're good. It's be 5 over 4.
Oh,
So it's 5 over 4.
5
Perfect.
over 4.
Okay.
16 plus 5. 21. Right, yeah. No.
No, you're good. We're just going to erase that. Make that an 8. Okay, now you're good. Okay.
Okay. Oh. Disappeared.
Just went away? What?
Yeah.
Ah, there we go.
Okay, so then we need to subtract this. 8 is the common multiple. Yeah. So 21 over 8. And then 2 or 4 times 2 is 8. So you have to multiply the 5 times 2. So 10 minus, and then equals 11 over 8. So now we have to put it into mixed numbers. So 1, 3, 8.
Okay, that was a little bit of a long way. You want to do the short way again?
Yeah.
Okay. So I'll trade you pins. So we'll write it in red over here. You just did the 2 and 5/8.
Minus 1 and 1. Or, whoops. So 1 minus 2 is 1. And then 5/8 minus 1/4 is so the common denominator is 8, and then 4 times 2 is 8, so you have to do that, and then 5 3/8, so 1 and 3/8.
Looks like they're the same.
Yeah.
Did a great job.
All right, there you go. Nicely done. Now, you can go ahead and erase the board. You've done excellent work with both of those. So I'm going to give you an option of your last problem to work on. Would you like to add or subtract?
Subtract.
All right, subtraction it is. Now, you don't have to do this both ways. You can do it either way you want.
Okay.
All right, so here we go. Let's find the next one. All right, 12 3/4 minus 6 1/6. So you can do it either the long way or the shorter way, whatever way you're more comfortable with, but you only have to do it one way this time.
So 12 minus 6 is 6. So just cross those out. And then 3/4 minus 1/6 is, so we have to find our common denominator. 8, which is 12. So 12. 4 times 3 is 12. So you have to do 3 times 3, which is 9. And 6 times 2 is 12. So you have to multiply the 1 by 2. So it's 2. That is 7/12. and then 7. Okay.
That was way easier than the other ones.
Yeah.
Huh? I know, right?
All right, nicely done with you two over there. Come on over here, Luke. Hey, we do have phone tutors available until 5:30. 636-4357 is that phone number. Don't forget, because you're in here, you now have a phone call credited towards your classroom, towards that 5th grade calling contest. So you've got about 40 minutes left on today's phone tutors. You can get a hold of people till 5:30. And then tomorrow is the final day for the 5th grade calling contest. So when you go back to school tomorrow, what do you need to do?
Ask my teacher about it.
Ask your teacher, what was it, Ms. Martinez, you said?
Yeah.
All right, so you can say, hey, listen, you heard about this 5th grade calling contest going on with Do the Math? She'll go, yeah, Luke, I thought you knew all about it too. And you're going to go, well, you know what? As a matter of fact, I do, because I was on the program yesterday, and I'm a step ahead, because you guys are working on fractions right now, right?
Yeah.
But you haven't got to mixed numbers yet, which is why I wanted to go to the next little section in your book, so that you kind of got a little head start on that right there.
Yeah.
So do you kind of feel comfortable with those?
Yeah.
Which way did you like better?
The minus, the one that you got to, the one that you didn't have to make an improper fraction.
Right. See, because if you can find little shortcuts and things like that, it's going to make life a little bit easier.
Yeah.
Right? Just like when you were doing the common denominators, instead of always multiplying them, you can look for the least common multiple first. And sometimes it just happens to be when you multiply, and that's what it is. It happens to be that. But always look for a shortcut if you can.
Okay.
As long as you have the concept of what you're doing. All right? All right. Hey, you know what? We do have an opportunity to go one more time out to Longfellow and visit with Devin and see what those guys are doing. Wrap up the afternoon. What do you got going on, Devin?
Hey, thanks a lot, Mike. Back here one last time here at Longfellow Elementary. I'm here with Imani and Malachi, 6th graders here. We were having an interesting conversation about greatest common factor. And, you know, factorization is always an interesting word to me. You know why? It's pentasyllabic. That means it's got 5 syllables in it, which is interesting because the word pentasyllabic has 5 syllables in it as well. So it's a word that kind of describes itself. But that's for do the English. Today we're going to do the math. And we're going to talk about greatest common factor. Now, the way that we're going to do that is we started talking a little bit with some of the other 6th graders in the room about how they found greatest common factor. And a lot of times it's a lot of dividing or trees or factors or multiplying up, we heard, as another method. And so I wanted to go back in time a little bit and explore how we can use geometry and how the ancient Greeks actually used that to develop their own method for greatest common factor. So let's go ahead and take a look up at the board and see what's set up here. So what we built is a rectangle. So could you guys explain this rectangle, describe it as far as its dimensions or what you notice about it?
Well,
It's way smaller than a square.
Okay, so it's got a lot of smaller squares in it, right? How would you describe how long this rectangle is?
12 and 8.
So it's 12 units across, all right? Let me go ahead and get them curl here. It's 12 units across, and it's 8 units tall. So now, I want to see if we can explore this a little bit, and I have a question for you. What is the largest square that we can fit into this rectangle? How large would that be?
8 by 8.
An 8 by 8 square. Could you do me a favor and kind of draw that out, and then once you have it drawn out, I would like you to do something. So let's draw out an 8 by 8 square. So it's 8 across, and Imani's drawing an 8 tall and coming back this way. So this is an 8 by 8 square. Could you do me a favor? I know this is going to hurt. I need you to cross it out. Goodbye, 8 by 8 square. We're going to get rid of it. It's gone. It doesn't exist. So let's describe what's left here. What do we have that remains from our original rectangle?
A 4 by 4.
Is this 4 by 4? So we have 4 across and...
4 by 8.
It's 8, right? Yeah. So we have a 4 by 8 rectangle. Malachi, what's the largest square we can carve out of that remaining piece?
4 by 4.
Let's get rid of a 4 by 4 square. Okay. It doesn't matter which one, whether it's on the top or the bottom. So he's going with the top upper right corner. Go ahead and cross that out. It's got to go. No love for you, 4 by 4. Now, what do we have left?
4 by 4.
So what would that be a square?
Yeah.
Okay, so we're left with a square. we're going to keep this one. This is a 4x4 square, which means the greatest common factor of 12 and 8 is 4. Now we could try that again. We can do this with any two values. We build a rectangle, carve out the largest square possible until we're left with just a square. So let's try this with a 16 by 6 rectangle. So let's find the greatest common factor of 16 and 6. So it's 16 across, 6 vertical. What's the largest square possible?
6 by 6.
6 by 6.
6 by 6.
I'll even start off on this side here. 6 by 6. Now, this rectangle that's left is still 6 tall, but now how long is what's remaining? Because we had 6 over here, we got rid of that. It was 16, we got rid of 6. What's left? 10. So now we have a 10 by 6 rectangle. What's the largest square possible we could carve out?
6 by 8.
Still 6 by 6,
Yeah,
right?
6 by 6.
So we'll get rid of another 6 by 6. Cross it out. We got rid of 6 from the 10, so now how long is this rectangle that's left?
4 by 4.
So it's 4 across, and how tall again?
4.
1, 2, 3, 4. Now that's going to be the largest square remaining, right? So we get rid of that. Now we got rid of 4 from this 6 and its height. We have 2 left and 4. What's the largest square remaining? 2. We'll get rid of that square. So what's left is a 2 by 2 square. It's a square, which means the greatest common factor of 16 and 6 is 2. Now this works with any two numbers, even when they're relatively prime. Even if the one square that you have left is just a 1 by 1 square, that means that the greatest common factor is 1 by 1. Now, we can take this as a shortcut. Instead of doing all of this rectangle work, we can just do subtraction and get to the same point. So let's try this. 16 minus 6. Those are our
10.
two values. What do we get?
10.
Now, here's what I'd like you to do. Get rid of the largest number here and subtract what's left. So what's left? We have a 10 and a 6. So we'll do 10 minus 6, which equals?
4.
Let's keep doing this. 6 minus 4 equals? 6 minus 4, because we have the 6 and 4
2.
left. We subtract it. We have 2. Get rid of the largest. 4 minus 2.
2.
It's 2.
Get rid of the largest. I'm going to get rid of that. So I have 2 minus 2, which equals?
0.
Once you get to 0,
The biggest common factor.
there's your greatest common factor. 2. 2. 2. That's all great. What do we do with that? If we had a fraction where these are our terms, we could simplify it and reduce it by that greatest common factor. So it's one step. Imani, Malachi, 6th grade. Hey, everybody, 4th through 6th here at Longfellow. A lot of energy, a lot of heads up, a lot of collaboration. Not bad for a first time go around. Hey, can we say thanks to everybody here at Longfellow Elementary? Guys, wonderful job this afternoon. That'll do it here from Longfellow. Mike, back to you in the studio.
All right, thanks for that, Devin. Nicely done with all of the students out of Longfellow. Luke, thank you for coming in today. And your final duty of the afternoon, you don't need to do the problem two ways anymore. Simply pull out one of the kids from Longfellow, and we'll find out who's going to a CSUB athletic event of their choice. And there we go, Malachi. So congratulations, Malachi out at Longfellow there. You've got yourself 2 tickets to a CSUB athletics event. Congratulations on that. And until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, California Resources Corporation, Kern Schools Federal Credit Union, Panama Buena Vista Union School District, Bakersfield City School District, and the San Luis Obispo County Office of Education, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.